Okay, so again, the even function is a function that's symmetrical about the y-axis. An odd function or odd functions will be functions that are symmetrical about the origin. All right, so I'm going to go ahead and redraw y equal x squared on a grid paper, so you'll see a little bit better. So remember, I'm graphing y equal x squared. I'm going to use a t-table. So if x is 0, what's y? What's 0 squared? 0. If x is 1, what's my y value? 1. If x is 2, what's my y value? 4. If x is 3, 9. Okay, what about negative 1? Let me put negative 1. Yeah, because remember, you're squaring negative 1, right? And so negative 1 times itself is 1. In fact, whenever you square, see how you're squaring x? So whenever you're squaring x, that's always going to be a positive number you end up with, or 0. So no matter what number I use for x, these y values better be positive unless it's 0 that I'm using for x, in which case I'll get 0. If x is negative 2, what's negative 2 times itself? 4. If x is negative 3, what's negative 3 squared? 9. Okay, so I'm going to plot those points. And when I plot the points, I get 0, 0, 1, 1, 2, 4, 3, 9, just like this. Negative 1, 1, negative 2, 4, negative 3, 9. Okay? And I'm not going to plot any more points because then it would fall outside the grids, and I'm not going to estimate. So then I'm going to draw my graph. Remember, it looks like a parabola. So all quadratic functions have the shape of a parabola, just like this. Do the best you can with drawing this. Okay. Now, remember, here's the question. I need for you to recognize, or let me rephrase it. The question is y equal x squared, which is a function, right? Is this a function, first of all? Yes, because it passes the vertical line test. Is that function an even function? Yes. It is an even function, because what's the definition of an even function? Even function is a function that is symmetrical about the y-axis. So if I take, let's say, this little piece right here, this right here, if I kind of trace over that part here, and I reflect it about the y-axis, don't want to get this part back? So I reflect this about the y-axis. I'm reflecting about the y-axis. You don't see it very well, but it was a reflection about the y-axis. I get this piece, right? Okay. So you can visually see that this function is an even function. That an even function is the easiest kind to recognize because you can see that symmetry about the y-axis. The other thing I want you to recognize is this. The distances, I want you to look at this in terms of distances as well. So the distance from this point here that I'm pointing to, that has coordinates 1, 1, from the y-axis, what's that distance right here? 1. On the other side, what's that distance? No, distance always positive. 1. This distance here, from this point here, what's that distance from the y-axis? 2. What's that distance? 2. This is 3, so that distance should be what? 3. The point is this. No matter what point you're looking at, let's say I'm looking at this point here, that distance from the y-axis better be the same on the other side. Okay? So that's the idea of that symmetry. So the symmetry idea. So if the point, listen carefully to these words, if the point 3, 9 is on the graph, and this is an even function, then what other point better be on the graph? Negative 3, 9. So the y values better be the same. So negative 3, 9. So the point, if the point, let's say, what was this? And this was 2, 4, is on the graph of an even function, then what other point better be on that graph? Negative 2, 4. So the x coordinates are opposites, but the y coordinates stayed what? The same. Okay? So a couple things I want you to recognize for right now about an even function. The distances, the horizontal distance from the y-axis is the same on either side. Okay? All right. Now, number 1, right, just number 1. Is this function an even function?
Yes.
Yes, you need to recognize that that is an even function. Because if you look at this, here's the y-axis, right? This is the y-axis. And so if you look at this, if I, let's say, choose this point here, this point, and if I look at that distance, you see what I'm doing? I'm taking the edge of a paper. I'm looking at the horizontal distance right here. So that distance better be the same as what? It's got to be horizontal. That distance here, right? Okay. So when I take this point and reflect it about the y-axis, do I get this point? Yes. If I take, let's say, this point here, and I reflect it about the y-axis, do I get this point? Yes or no? Yeah. So those distances better be the same. The horizontal distance better be the same, meaning that from here to here better be the same as what? The other side. And it looks like it is, right? Okay? So do y'all see that this graph, this function, is an even function because it is symmetrical about the y-axis? Okay. All right, look at number, so this is an even function. It is symmetric about the y-axis. Look at number 2. Number 2. Is this quadratic? Now that's quadratic function because it's a your graph is a parabola. Is that function an even function? No. Okay, that's not an even function. Now we're going to come back because we haven't talked about an odd, right? All we've done so far was talk about even function. Well, let's now talk about an odd function, and then we'll come back to number 2. So I'm going to go back to that grid paper, and I'm going to draw an odd function for you. So we know that y equal x squared is what kind of function? Even. Y equal x cubed is going to be an odd function, by the way. And some students remember this idea. You see, there's only one term here, x squared, right? What's that exponent? Which is even. What's this exponent here? Only one term, though. One term. What's that exponent? Odd. So I'm going to draw an odd function. So this is going to be an odd function. So I'm going to do a t-table. So this is going to be an odd function, okay? I'm going to draw a t-table. Use a t-table. If x is 0, what's 0 cubed? 0. So I plot the point 0, 0. If x is 1, what's 1 cubed? So I plot the point 1, 1. If x is 2, what's 2 cubed? 8. So I plot the point 2, 8. And that's about all I can do. If you do 3, y is going to be 27. I don't have that y value of 27 here. If x is negative 1, what's negative 1 cubed? Negative 1. If x is negative 2, what's negative 2 in parentheses cubed? Negative 2 times negative 2 times negative 2 is a what? negative 8. So negative 2, negative 8. And again, that's about all I can do in terms of using integers. So I'm going to draw the graph and look what the graph looks like. Looks something like this. It's going to be a curve, just like that. Do the best you can with drawing this. Just do the best you can with drawing this. Looks something like this. That is y equal x cubed. Okay? Now remember, you can see from here that that's not an even function, right? Because an even function has to be symmetrical about the y-axis. Obviously, this part of the graph is not, you don't see it here. Let's talk about what if this is an odd function. An odd function is a function that is symmetrical about the origin. So remember a while ago when we talked about an even function, we talked about in terms of distances, right? So if I take this point here, reflected about the y-axis, that distance may be the same as that distance. If I take this point, reflected about the y-axis, that distance better be the same as that distance. Okay? If I take, remember this point here was 2, 8 right here. I'm going to put this 2, 8 here just to kind of show you. If I take this point here, listen carefully, and this is the origin. Y'all agree that's the origin right here, right? Where the x and y axis meet. If I take that point, reflected about the origin, now remember, when I took this point, reflected about the y-axis, we looked at distances. That distance from the y-axis better be the same on the other side, right? So let's talk about the origin now. So here's the origin, right here. Here's the origin. And here's that point right here, right? So let's look at that distance. Oops. Right here. The paper has got to go through the origin. Right here. Y'all see what I did? That distance. So from this point to the origin, that's that distance right here, right? Okay, if I go straight through the origin like this, and then look at, and then go here on the graph, do y'all see that 2, 8 becomes what? Negative 2, negative 8. So meaning this, is this distance from the origin, that straight distance, the same as this distance? Yes. Yes, it is. Who said no? It's all right, but do you see it is though, right? So look, if I take this distance right here, that's going to be the same as this distance. You see what I did? All right. Now I want you to notice the chords. The chords are going to be important for us. This is an odd function, correct? 2, 8. If this is an odd function, 2, 8 becomes what? Negative 2, negative 8. So both coordinates, the sign changes. Look at this point here where we had 1, 1. Think about what it just said. If 1, 1's on the graph and this is odd, then what other point better be on that graph? Negative 1, negative 1. Is it?
Yes.
Yeah. Now here's what that means. Now, if I go back to this point right here, that 1, 1 right here, and look, I'm just looking at distances for right now, just to show you from the origin, distance from the origin, okay? Distance from the origin. Here's the origin right here. Here's that distance. If I go back here, you can't see it very well because the distance is short. That's this right here. So if I look at this point here, let's say this point right here that I'm marking big circle right here. If I take that point reflected by the origin, am I going to get a point of the graph where the coordinates are going to be opposites?
Yes.
I should. So I'm trying to pick a side that I don't have any marks on. So this right here, right? Here's the origin right here. That I'm going to take this part here, go to the origin, and then rotate it until it touches the graph, this right here. That's this right here. So when I reflect this point about the origin, I'm going to get what? That point. So I'm going to estimate that this is about, I can't say 2, right? Because 2 is here. So I'm going to say about 1.9 comma, and then my y value is about 5.9, let's say. So this should be about negative 1.9, what? 5.9, it looks like it is. Okay? So the odd one's a little bit more difficult to deal with, but an odd function, if I take every point on an odd function and reflect it about the origin, the other point better lie where? On the other part of the graph. And the coordinates better be opposites. Yeah, I mean, if it's here, it'll be on this side. So basically her question is, when she said opposite side, she really meant this, that if my graph's in quadrant 1 and are reflected by the origin, then it's going to end up in quadrant what? 3. If my graph's in quadrant 2 and are reflected by the origin, it's going to be in quadrant 4. For an even function, if my graph here is in the first quadrant and are reflected by the y-axis, it's going to be where? In the second quadrant. If it's in the fourth quadrant and reflected about the y-axis, is going to be in the third quadrant. Okay? All right. Now, let's go back over here. So the odd was a little bit more difficult to visually see, but I need for you to understand this in terms of distances from the origin. And I also need for you to kind of know this now, that if the point 2,8 is on the graph of an odd function, then what other point better be on it? -2, -8. So we go to number 2. Here's going to be the question that's going to be stated. Is this function even, odd, or neither? Neither. So neither meaning neither even nor what? Odd. So this is neither. So this is neither even nor odd. Okay, now look at number 3. The next page, number 3. Now, you're going to do things like number 3 at the end of the course. So you're going to end up graphing. Now, we don't have much time left this semester and for this Saturday class. But I'm hoping we can get to this point right here. But we need to do exponentials and logarithms also. So we'll see where we end up. But this is a graph of a rational function. That's the graph of a rational function. Is this function, now this is a function, right? Because it passes the vertical line test. Is this function even, odd, or neither? Huh? You think it's odd?
I think it's even.
You know it's not even, right? So you know it's not even. Because even would be symmetrical about the y-axis. So meaning that if all you had was this, then you better have this piece as well, right? But is it odd? If I take this point here, 1, 1, and I reflect it by the origin, am I going to get the point -1, -1 on the graph? Yes, I do. But let's look at this in terms of distances from the origin. Here's the origin. Is this distance right here the same as that distance? Yes. Let's look at this distance right here. I'm looking at this point right here. You see what I'm doing? I'm taking this point. I'm looking at from the origin. So I've got to make that paper go through the origin, and it's hard to do that here. Where we don't have a tick, any marks. Okay, so this point right here through the origin. All right, so from here to here, is that the same as from here to here. Yes, and here's a question. So if I reflect this about the origin, do I get this right here? Yeah. So you need to visually see that this right here is an odd function. So if I take this point here, where it's 3 something, right? And I reflect about the origin, I want you to notice this. If I take this, reflect about the origin. Sometimes you take a ruler, it might be a little bit better for a ruler. So if I take this point here and go through the origin, you see it right here from here to the origin? And kind of think about the distance from here to here. So it kind of went through here, right? The ruler? Yep. So here's the point. The ruler goes through this part of the graph. The question is, when I reflect this about the origin, is it really this right here? It is. So if I take this right here, go through the origin, this right here. So is this point, when I reflect about the origin, actually this point? Yeah. So if I go back to the one where we drew the function x cubed, and look at this in terms of the ruler then, see this point right here? This right here, here's the origin, make it go through the origin. The ruler touches the graph here. Y'all see where it touched the graph here? So is this distance from here to the origin the same as from here to here? Yes. Yes. Is this right here, go through the origin. So from here to the origin, is that the same as from here to here? Because that's where the ruler touched the graph or went through the graph. Yeah. All right. So if you need a ruler to help you, because it's more straight than this paper was, I kept having to move it. Then you use these as aids. All right, so this is an odd function, correct? Is number 4 even, odd, or neither? Even. Y'all can easily see an even function, so that's even. Because look, if I take this point here, right here, take the ruler, make it go horizontal through the y-axis. Is this distance right here? Now remember, that's where I went through the y-axis, right? I'm sorry. That's where the ruler went through the graph, right here, right? Okay, so is this distance the same as that distance? Yes. And in fact, if this is 2, 2, then this better be 2 what? I'm sorry, negative 2 what? 2. So the y-coordinates stay the same, the x is different. The x's are opposites. The x are opposites. So right here, if this is 3, 1, and that's an even function, then what point better be on the graph? Negative 3, 1. The y, it's very easy to see that the y-coordinates stay the same, right? You understand the y-coordinates stay the same, right? Because this point, when you reflect about the y-axis, that height stays the same. It's still the same y value. But what's different? The x. Because remember, you're reflecting about the y-axis, so they're going to be opposites of each other. So that distance from the origin, from the y-axis, is on the opposite side. So they're opposites. So this right here, this is 6, negative 2, and I reflected about the y-axis, the y better be the same value. What's going to be the opposite? The x. So negative 6, negative 2. All right, so it's easy to see an even function, but it's also important that you remember about these coordinates. So when you reflect a point, if you have an even function and you reflect the point about the y-axis, the y-coordinate stays the same, but the x-coordinates are what? Opposites. If you take a point, if you have an odd function, and you take a point, remember an odd function is symmetrical about which part? The origin. If you take a point reflected about the origin, both the x and the y's are going to be opposites. Okay? All right, number 5, look at the graph for number 5. So number 5 is, so there's probably 2 left on this handout. This right here. Even, odd, or neither? Huh? Neither. Oh, you have the wrong, oops, sorry.
No, we have the one you're.
Oh, okay.
We have two.
Oh, I see. Okay, so that's neither, right?
Yes.
Okay. Neither, neither, potato, potato. 6. Huh? Is that what? Is that R?
She's talking about 6. No, it's neither.
Oh, is that all of you?
I say they're all odd.
Oh, I'm so sorry. You know, I have tinnitus, I have ringing in the ears, among other things in my life. Yes, that would be an odd function. Yes. So obviously, you know it's not even. So the only other thing you need to look at is it odd? So if I take this point here, see what I'm doing? If I take that point here, use a ruler to help you. Go through the origin like this. The ruler touches the graph here. Y'all see it? And the question is, if I take this right here, reflected about the origin, do I get actually that point? So in other words, whatever the x and y coordinates here, are these going to be the opposites? Yes. So if I take this point here, see right here? Look what I'm doing. This right here. Reflect, make sure it goes to the origin. All right. Is that distance right here going to be the same as that distance here? Yeah. And whatever the x and y are here, whatever x and y is here, then this is going to be negative x what? Negative y. Okay? And we can estimate what that is. Let's just kind of guess. It looks like, God, these are in tenths. So let's say this is what, 7 tenths, 0.7? And what's that y value right here? Negative 0.4? 0.7, negative 0.4. Y'all see what I did? Right here. 0.7, negative 0.4. Let's see what I did, right? Okay. The question is, remember, this says I take the opposite of the x and y. So is this a negative 0.7, comma, positive 0.4? Does it look like it? Yeah. Okay. All right. But use a ruler, if you need to, use a ruler to kind of help you to see, like if I take this point here, just like I did, and go through the origin. And the graph and the ruler intersects the graph here. So I'm going to put a dot here. Is this distance the same as that distance? Yeah, it is. I mean, you can watch. You can take a piece of paper if you want to. And so every time I move a paper, it's hard to make it go where you want it. Okay, so that distance should be the same as that distance, and it is. I just, the paper is hard to deal with. It's a little off. You'll see it kind of looks like it is. Okay? All right, and then y'all said there was another one? Okay, so let's see, number 7. Okay, number 7. All right, so he already says that both of those should be what? Even?
Even.
So no matter what you take here, let's say you take this point right here, reflected about the y-axis, is that distance the same as that distance?
Yes.
Yes, and even if I take this one here, you see what I did right here? Reflect that about the y-axis, do I get this point here? Yeah, if I go and I look at this right here, is this point, when I reflect it about the y-axis, is at that point? Yes. All right, so this is what kind of function? Even, so that's an even function. And then here, is that even, odd, or neither? That's even, right? So if I take this point here, reflected about the y-axis, I get that point here. If I take this point here, reflected by the y-axis, I get that point here. Okay? All right, so that's even as well. Okay, was that all of them? Okay.